We usually picture Jupiter like this: serene, swirling bands of cream and orange, spinning quietly in the dark, alongside that famous red spot. Look at this visual comparison. If you take every other planet, every moon, and every piece of asteroid debris and put them together, Jupiter is still 2.5 times heavier than all of them combined. During its formation, if Jupiter had collected about 80 times more mass, the immense internal pressure would have ignited nuclear fusion. We would be living in a binary star system, and the delicate conditions required for Earth to form would likely have been erased entirely. Jupiter is a cosmic monster. It conceals a world of crushing pressures and lethal radiation behind those elegant outer clouds. To fully grasp the threat this planet poses, we have to strip away the facade. Now, we need to fall from the distant reaches of its orbit directly down into its crushing core. This generated map of the inner solar system shows Jupiter's true reach. That highlighted sphere extending far beyond the planet itself is its gravitational well, the outermost zone of danger. Early in our solar system's history, Jupiter migrated inward toward the Sun. As it moved, it scattered debris and absorbed developing worlds. This inward march stunted the growth of Mars by starving it of the raw materials it needed to reach Earth size. Today, it acts like an active gravitational vacuum cleaner. Comets and rogue objects drifting through the darkness are caught in its pull, either flung out into deep space or dragged directly to their doom. We watched this happen in real time in 1994. Comet Shoemaker-Levy 9 got too close, shattered into fragments, and slammed into Jupiter's atmosphere at 60 kilometers per second. The impacts released energy equivalent to millions of nuclear bombs, leaving the massive black scars you can see right here. Even its own moons fare no better. The extreme gravitational tidal forces constantly knead the moon Io, generating so much internal friction that its surface is trapped in a permanent state of violent volcanic eruption. The history of our solar system is written by Jupiter's gravity. It decides what forms, what gets destroyed, and what survives today. Moving closer to the planet, we hit an invisible, lethal wall. This simulation displays Jupiter's magnetic field, a pulsing barrier stretching millions of kilometers across space, roughly 20,000 times stronger than Earth's. As solar wind hits this field, charged particles are trapped and accelerated to near light speed. This creates localized radiation belts so intense they would kill an unprotected human in a matter of minutes. When NASA sent the Juno spacecraft to orbit Jupiter, they had to lock its sensitive electronics inside a 200-kilogram titanium vault. Even armored like a tank, Juno can only dip into these radiation zones for a few hours before risking total system failure. That radiation continually blasts the moon Europa. The exposure completely sterilizes the surface, meaning if we want to search for life there, we will have to drill through kilometers of thick ice just to find a shielded zone. While Earth's magnetic field shields life, Jupiter's field operates as a lethal defensive perimeter that destroys everything in its vicinity. Finally piercing the outer clouds, the true nightmare begins. There is no ground, no solid surface to ever land on. You simply fall through a violently chaotic storm of swirling gas. Down here, jet streams tear across the planet faster than the speed of sound. And that famous Great Red Spot? It's a localized hurricane large enough to swallow the entire Earth, and it has been raging for at least 400 years. As you sink deeper, the atmosphere grows thicker. The ambient pressure compounds with every single kilometer, crushing inward. This cross-section reveals the physics at the bottom. Extreme pressure compresses hydrogen gas into a dense, glowing state called liquid metallic hydrogen. Because it acts like liquid metal, it conducts electricity. The rapid spinning of this massive ocean creates an internal dynamo. Jupiter's most destructive outward features, the raging storms, the light-speed radiation belts, the massive magnetic field, are all powered by the crushing physics of this alien core. So why do we send spacecraft, like the Galileo probe seen here, directly into this meat grinder? Because surviving these extremes offer immense scientific value. The liquid metallic hydrogen and the lethal magnetosphere act as an active laboratory, showing us exactly how gas giants form and behave across the universe. Jupiter represents a hard physical boundary for humanity. We can observe it from afar, and we can briefly throw heavily armored robots into its orbit, but the physical laws of the planet prevent us from ever walking its surface or settling its clouds. It has sat in the dark for 4.5 billion years. It was crushing comets and churning out lethal radiation long before the first single-celled organisms appeared on Earth. Jupiter remains an apex survivor, a violent, hungry ruler that has held its throne for eons, simply because nothing else in the solar system can withstand its presence.